We are Group 6A, Matt, Ryan, Cole, and Quaid, and we are drainage problem number 6. So our deep tee box is located on a 40-foot high retaining wall with another retaining wall that runs along the back. It's a pretty small tee box. It is only 300 feet squared, but since it is located above this 40-foot retaining wall, there is only one entry and exit point for golfers and equipment to enter, which has caused a high deal of compaction. The tee box is also described as relatively flat, which is a cause for poor surface drainage. There's currently no subsurface drainage either, which could be another problem for the puddling problems we are having, but likely not the main problem, because if the ground is compacted, the water wouldn't drain low enough to reach a subsurface drainage program. Compaction is our main issue because of the high traffic, all leading to one area, since there is no other way to access this tee box. Compaction has the ability to drastically lower infiltration rates due to the fact that the soil becomes more dense and makes it harder for water to travel through. This in turn will cause puddling on the surface, which is what we have. One of the main points we came across when initially building a tee box is that it should have a 0.5% to 1.5% grade slope for surface drainage purposes. This grade is almost unnoticeable to golfers and super important for drainage issues. Our tee box is relatively flat, which we think is another one of the big reasons that water is puddling on this tee. No subsurface drainage was our third identifying issue. We think this is our least significant issue because the other problems are a surface drainage problem, which would need to be fixed before subsurface drainage could even be addressed. We can't be fully certain subsurface drainage is the cause for puddling on this tee because the compaction slope need to be addressed first. Subsurface drainage installation would be our third option if improving compaction and surface drainage are insufficient to fixing the problem, which we don't believe they will be.
Option 1 will be a top dressing and aeration program for our tee box, also with a resloping of the tee box. So we will be resloping the tee box at a 1.5% slope grade, and that will help with surface drainage towards the low end of the tee box and help get that extract water off and out of the way of the tee box. For aeration, we will be using a 3/8 tine, hollow tine, so we'll be pulling cores. And for our top dressing program, we'll be using 1/8 of an inch top dress. Ultimately, our top dressing and aeration program will help the overall infiltration of the ground. It'll help get that water down into the root zone and help the ground absorb more water. And overall, we will have less standing water on the tee box. It'll help with that compaction as well as also reduced thatch levels, which can always hinder on the drainage of the ground. So ultimately, option 1 will be a great way to in-house do some drainage work and also help the health of the turf. When we resold the tee box, we'll be resodding it as well as adding about 2 cubic yards of loam for our overall resloping of 1.5%. And it'll take about 2 days, and it'll take 2 guys 2 days to do it. So overall, our cost will be around $685 for the total project on our option 1. As far as costs go, we will be needing about 300 square feet of sod for the resurfacing, which is a total of $120. We'll need some added loam, which is the 2 cubic yards, and that's around $70. For our labor, we will use 2 guys, and it'll take 2 days. Each guy's going to be making minimum wage at $15 an hour, so we'll have a total labor of $480. For the aeration and top dressing, it'll take a total of 1 hour to aerate and top dress and clean up plugs since it's such a small tee box, only 300 square feet. And that is 1 hour of labor, and that's $15. Our top dressing sand will all be on site, so that's not a cost issue. So the total cost of option 1 will be $685.
Okay, so the option number 2 we've been considering is called sand slit drainage. So this uses 2-inch perforated pipes, and it's installed at a depth of 12 to 15 inches on the surface. So you use a machine that creates a 3-inch wide trench, and you insert the pipe beneath the ground. And then you connect this pipe to a larger connector pipe, or in this case, because we do have a large retaining wall off the front, we would just send it right out of the retaining wall. So the narrow trenches are then backfilled with the sand, which creates a permeable layer towards that outside edge. And then so this sand is something that's waters really can flow freely through, and it'll be collected, as you can see in the picture here. This is what the finished product looks like, and excess water on top can flow through that sand and exit the area. So next we kind of needed to decide what spacing needed to be used. So we used the Hoghout formula for this. According to the U.S. Department of Agriculture, we found that sand is between 42 and 141 micromillimeters per second. I chose to use 100 micromillimeters per second just to be safe. Seems like a very large range in there. So this is the K coefficient in our formula, and the drainage will be installed 15 inches into the ground, which is converted to 38 centimeters. Next, for the suitable spacing, our tee box is only 15 feet wide and 20 feet long, so that will define our spacing. We don't have quite a bit of room to work with. So another thing with the sand slit drainage is it's normally used in fairways and in sports fields. So it uses a larger surface area, so it might not be suitable for a small area like a tee box. Like we could only have 2 slits, so it'd be 2.25 meters apart, and which we were able to find our drainage coefficient. So we used the Hoghout formula, and we got the K coefficient to be 360 millimeters per hour, and we had 38 centimeters beneath the ground, 2.25 meters spacing, and that comes up to 41.073 millimeters per hour, which is 4.1 centimeters per hour, which is a relatively good drainage rate. All right, so the costing of this would be relatively cheap because it is such a small surface, so we don't need a huge amount of sand. So I'd say 1 cubic yard, which is equivalent to 1,296 inches squared, which we only need 45 inches squared, so that'll be $30. Drainage tile, 2 20-feet sticks, will cost us $20. Machine rental, I was unable to find what the actual machine rental would cost, but we're just going to go with it's $350 for the day. That brings the total cost for this option to $400.
So option 3 would be subsurface draining. The only problem with this is our tee box is highly compacted, so to put in subsurface draining would not affect this as much at the moment. But if we were to do that, you could have either a herb bone or a random placing of your drainage tiles, because it just makes more sense for the 300 square foot area. With a herb bone design, it goes in one line will go up the middle, and then it'll branch off in diagonal areas, where a random will just go to certain areas that have puddling of water. So with the subsurface drainage, you would place it to about 2.5 feet deep, which is 0.67 meters, with a 7.5 foot spacing, which is 2.3 meters. With this, I had to do a Hoghout formula. With this, your K portion would be 32.4 millimeters. My H squared is 0.76 meters. My S squared is 2.3 meters. So you'd go 4 times 32.4 millimeters per hour times 0.76 times 0.76 divided by 2.3 meters divided by 2.3 meters, which equals on the top at 74.86, and on the bottom 5.29, which is 14.15 millimeters per hour. With this, you would have a cost for everything. So your 30 feet of 4-inch drainage tile would be $12.30. Labor would be about $15 an hour, 7 hours for two guys, be $105. Sod cutter is $76 per hour. You need it for 2 hours. It's $152. Trencher to dig your trench, $80 per hour for 2 hours would be $160. So your total cost would be $430.
All right, so what option are we going to choose? We decided on option 1, aeration, top dressing, and regrading. Why do we pick this option? Because it is the most sustainable results over time. Compaction has developed due to foot traffic, and there's no previous evidence of aeration. Aeration with a combination of top dressing helps relieve compaction and begins to alter the soil type beneath the turf. When compaction is relieved and the sandy content in the soil is higher, there will be more of a permeability within the soil, which will allow the water to move through the surface faster. This will improve the overall infiltration rate on the tee box. Next, the tee box must be regraded. This means the entirety of the tee box will slope from back to front at a 1.5% grade. This will help to disperse any water not able to be taken into the ground towards the front of the tee box and off the edge of the 40-foot embankment. The process of aeration and top dressing will take a few years to totally relieve the compaction and add appropriate amount of sandy layer into the current soil texture, but regrading the tee will be instant improvement. We went with this option because it has the most sustainable results. We found through our research that subsurface options should not be necessary on a tee box of this size. Subsurface drainage results in play interruptions and can be invasive. Surface drainage must be addressed before any subsurface drainage can be considered on a tee box of this size.